So to start things off, I'm going to talk about the task system refactor. So all the engine tasks are currently owned, or well, most of them are owned by the task manager. There are a few exceptions, and I'll get into them later. So the task manager has all these tasks in here. And if you look in here, when you set the multi-thread mode, I'm not going through all those tasks and assigning children. And the reason I did that now is our whole task system is effectively a behavior tree. So main loop start has 3 children: render frame start, update frame, and process audio commands. And then update frame has 1 child, render frame or post frame start. Sorry. So now that we see the kind of parent-children idea. Oh, also, when you assign a child, it's implied that the inverse is true. Like render frame, when you say main loop start, your child is render frame start, that's also implied that render frame start's parent is main loop start. And you can have multiple parents and children. I know it's silly, but it works for what I'm trying to do. So, the engine task. The reason why I do this, these parent and child tasks, is now we can have this atomic integer. So, quick refresher, atomic integers are a cool feature of C++ that are best case scenario, lock-free, worst case scenario, they're locked. So, regardless of which case they are, they're always thread safe, meaning whenever you interact with it, it's always going to be enforced to be controlled across all your threads. At worst case scenario, when it does use a lock, that's not a big deal. And best case scenario, when it's lock-free, you get a nice little bonus there. So why am I so excited about this integer? So here's when you execute an engine task. You gotta start your tracking, stop your tracking, execute children, do your work, and then this idea of the execute children. Terrible naming system, I'm sorry, but it follows, so I'm leaving it. So what you do is you go through all your children and say inform parent is finished. What that does is decrements that dependencies remaining. Oh, sorry. And that dependencies remaining, right, set right here. Whenever you assign a child, you set this value. So dependencies remaining is equal to the number of parents you have. So what's awesome now is, let's say, post frame start right here. You see he has 3 parents: update frame, render frame end, and process audio commands. So let's say update frame finishes. He gets down here, decrements dependencies remaining. It is now 2. That is not 0, do nothing. Render frame end, decrements it, it's now 1, not 0. Process audio commands, it is now 0. Now process audio commands will then execute post frame start. And what's awesome about this is now it doesn't matter who finished first. For all I care, render frame end could finish first and it doesn't matter. All that matters is that one of the parents is going to be the one that gets to the 0. And then he will kick it off. So update frame could kick off post frame start, render frame end could kick off post frame start, or process audio commands, and it doesn't matter. All that matters is all 3 need to be finished before this gets kicked off. And that's why I love this system. In the previous system, I'll go deeper into this and then I'll add why this is awesome. So, an example of this, the main loop start. What you do is just inherit from EngineTask and override the work function. So when you go in here, on the constructor, you have to give it a name and give it a priority level. We're not using priority levels for now, but I wanted to enforce this as a standard. So main loop start is currently not doing much anything interesting. This is mainly for me keeping this nice and clean. And I'll be honest, we've found a lot of cases where having these little small tasks that do just quick amounts of work to flip things over in between these huge waves is helpful, so I'm leaving it for now. So, a more interesting one, let's do update frame. As you can see, inherits from EngineTask, overrides the work function. And here we go. It executes the update step. Ta-da! So now you get all that multi-threaded logic with all the parents and children for not even 18 lines of code. Most of this is white space. And that's why I love this, because it's just one function. And you can grab more complex ones, like with M-lines. Well, these are all one-liners. Oh, here you go. Resolve frame. Ta-da! You can add and remove all this logic to our engine about like how the main loop works just by removing a few lines of code in here. So, now why is there only the engine task? In the previous quarter, we had the idea of synchronous and asynchronous tasks. So what I realized was an asynchronous task is just a task that doesn't have children. That's all. He's just someone that you can let go, and he doesn't kick anything else off. He's just on his own little world. And that's where this guy's awesome. Because if you never assign a parent, dependencies remaining can never be triggered because you never have any children. So whenever you finish, you never kick off any children. And you'll notice this handy guy here, on work complete. So, here we go. So audio data is expensive. It's really, really heavy. So early in the engine, I wanted the idea of being able to load your audio data asynchronously. So let's say I have this big chunk of audio that I want to load it for the next scene that's going to be upcoming. So what I can do is set off an engine task to load that audio data while I keep working on the main game. And then when it's done, I can then swap over the scene, and I know that audio data's already been loaded, and it's ready to be used by all of my audio emitters. So it's a nice way of kind of preloading things that you're going to need. And here's all you have to do. You create this engine task called load audio clip. And then here's some case-specific stuff about the clip name, file name, yada, 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 work. And now you have this handy function, on work complete. So why is he handy? Is in the case I just talked about, load asynchronous. Here we go. So here's loading. You go into your array of audio clips and you load it. That's it. But what's really cool about load async was what he's actually doing is he's just calling that same load function on an engine task. So what you can actually do in here is when you say to load asynchronous, he's got a mutex just to keep things safe. What he does is he has a pool of these engine tasks. He pops one off, initializes it, and then calls the execute asynchronous, which execute asynchronous will then toss this engine task onto the work queue. And then once it's done, it'll do on work complete, and then you return this engine task back into the queue. Ta-da! Or back into the pool. And so now you can have all this multi-threaded logic that is essentially just a command. All the work you need to request a worker thread is just a command. That's it. You just inherit from engine task, make a pool of them, and tell them to execute. And that's why I love this system, because we've taken the idea of synchronous and asynchronous and just thrown them out the window. And so now we can do all this complex inheritance, not complex inheritance, complex dependencies in the main loop, simply by going to the task manager and swapping parents and children around. And I added there's a bunch of other functions in here for like printing children, printing parents, and reporting average speed. That's largely debug stuff. Don't worry about a lot of that. The stuff you actually need to make the engine work is just right here. That's it. Oh, and there's single-threaded. Single-threaded treats these as just tasks without children. Again, why I love this system. By just swapping around your parents and children, you can make these act like a single-threaded object. You can make them act single-threaded, or you can make them act asynchronous, you can make them act synchronous. It doesn't matter. All that matters is how you specifically manipulate the data on that object. And I go deeper into the paper about the pros and cons of the system, specifically how, in here, this is one of the biggest problems. In here, execute children, it's right here, execute async. What he's actually doing is that this thread is executing the engine task. Well then, so let's say an engine task has 3 children that all can be successfully, that are all, here, let me take a step back. Okay, main loop start, he has 3 children that both only have 1 parent. So what he does is goes through every single one and tosses them onto the work queue. But when he does that, update frame now gets assigned a worker thread, he goes to work. Render frame start gets assigned a worker thread, goes to work. Same thing for process audio commands. So now I just kicked off 3 threads while this 4th thread is still going. And that is the biggest problem with this system. I'll be doing more tweaking with this in the future, seeing if I can essentially like scuttle away one of my children that was successfully ready to be executed and saying, I want to execute that on this thread. But that gets a bit more fussy. I'm not certain. I can see some potential for... What I'm worried about is one thread getting lost in a whole chain of workers. I don't think it's going to be a huge problem, but it's too late in the quarter and I don't have time to address this right now. So, there are issues with this system, but it's a huge leap forward, and I fully recommend this design to anyone that has any questions about how to do multi-threaded engine. I think that this is a huge leap forward in the right direction. Obviously, it needs a lot of love to make it more performant, but it's by far the most flexible design I've had yet.